Hello and welcome back to the shed. It's been a very busy time lately. I haven't been able to make as many videos as I wanted to. I've been filming everything I've been doing, but at the same time as the fun stuff has been going on, I also changed job, which was an involved process, let's say. And so I've had to get up and running there, and that's just got in the way of things a bit. And doesn't it just piss you off when earning money so that you can do the fun stuff you want to do gets in the way of the fun stuff you want to do? Still, that's life. Anyway, I've had a number of new channel stickers arrive, which is phenomenal, and I'm really enjoying striking up a few email conversations with people all around the world who have similar mindsets to me in terms of making things and machining things and model steam engines and all that. So, and I had promised a couple of them that I would be previewing their channels in this episode, but I haven't yet managed to find time to do the filming necessary for that. So that will be in the next video that I release, I promise. But before we get on to today's Shednanigans, I would like to dedicate this episode to all of the people that I worked with at my last job, and I wish you all the very best. It was 8 wonderful years getting to know you all, and I certainly hope we don't lose touch. I'm honored that some real craftsmen and women are actually watching and following this channel, and hopefully they're not too cringeworthy for you, but that's definitely not the end of that episode, and we'll be seeing you all in due course. So I'm really looking forward to that. And one final thing on that, my very good friend Buzz retired from that very company today, and so I want to wish him all the very best. I know he follows this channel, and I really appreciate that. I appreciate everyone that follows along. I really do. So Buzz, happy retirement to you, and I'm really glad that I got to work with you and all the other fine people. So with that, let's get on to this little project, which is the largest thing I've ever made, and quite a challenge just because of the size aspect on the small machines that I have, and you'll see what I mean as we get into it. So let's do it. That's a cracking pair, isn't it? 16-inch diameter, 2.5-inch thick stainless steel slugs. Got these scrap, and I'm going to turn them into a pair of tractor wheel spacers for a local farmer friend of mine. Right, first things first, I got to get them up on the mill, machine them flat, and put a bolt pattern in. These are 150 pounds each, and as mightily strong as I am, I'm not going to heft them. I'm going to have to use some help. The next step is to put a 3/8-16 tapped hole in the edge of that plate for a lifting eye. This will be very important in setting it up on the lathe, because I ain't lifting that up there by hand. Right, let's have a look at the part. Relatively simple, as you can see. Just a big disc, two different bolt patterns, but they're on the same pitch circle diameter, a set of blind metric holes which match the lug bolts that are used on the tractor, and then a set of through holes which have a chamfer inside here to match the lug bolt, and then a boss one side to locate the part, and then a recess the other side to locate the wheel. Not actually that complicated. Let's have a look at the drawing. So I find the drawing a useful thing to have just for planning, really. I can work through a number of different scenarios on something like this, which requires a bit of thought in terms of moving it around and holding it and clamping it and everything else, and kind of think through the issues that are going to happen. And this is not what I normally call an engineering drawing. It's a bit of a mess. This is a result of adding reference dimensions as I've worked through this process to figure out where I'm going to leave stock and where I'm going to hold the part, and what order I'm going to do things in. So useful exercise and useful reference to have as I go through the process. So let's get to the real thing. What I've got going on here is just mapping out the flatness of the part. Part is just clamped arbitrarily to the table, and I'm using an older used test indicator that I bought, and all I'm doing is tramming that across the part, and as you can see I've written down numbers on various points of the part to understand where it's falling off and where it's high. And having done that, I've established that it's out of flat about I think it was 20 or 30 thou, which actually is pretty good, and that just gives me an idea what I'm going to have to remove in order to clean up the surface. If it was really bowed badly, then I'd probably have to shim it up and adjust it and try and best condition it, but this particular part worked out okay. And so here we go, a little fly cutting to clean up the majority of the surface. I made this fly cutter from a chunk of scrap 304 stainless, and I really wish I'd filmed making it because it was a fun project, went really well. Maybe next time. Having fly cut this surface, or the majority of it, and got it flat, what I'm now going to do is get the two bolt patterns put in place. I'm not going to completely clean up the surface because I don't need to. The final part is going to have the outside perimeter machined down significantly, so it doesn't matter that this area isn't done yet. There's enough that's flat to get the bolt pattern in and to get that securely on the faceplate on the lathe. I need a simple way to find center of this part, so what I'm doing is just drawing at least 2 chords on the part, and then you mark the center position of each chord, and then draw a line from the center position perpendicular to the chord line, and then where those lines cross is the center of the part. Now you only need 2 lines to do it, and the chords do not have to be the same length. They can be anywhere on the circle. You just need to find the center point of the chord and then come out perpendicular. I'm using 3 lines here just to help eliminate error and get the center mark as close to the actual center of the part as possible, because this being a rough water jet slug, there's no way it's round, so I'm just finding the best average center I can. Is one of the features that I like on this DRO in particular is just the graphic interface. So I'm going to put a bolt circle in here, new. We've got the 0 set to the center point. Let's see. Circle radius is 4 inches. Starting angle is going to be 0. Number of holes is 16. There's actually 2 different bolt patterns, but they're both on 8-inch pitch circle diameters, equally spaced. So the tapped holes are mixed in with the counterbore holes. So we can do a center mark for all 16 in one hit. Number, and then depth we're not going to worry about on this. Plane is XY. So run. Now it gives you just a little graphical representation of where your drill is and where your next hole is. That just helps you track where you are, and then you've got the actual coordinates here. It's just a nice touchy-feely way of having the DRO. Speed. So we've got center drill positions for all holes now. First set of 8 holes are going to be tapped M14 with a 1.5mm pitch, and they have to be 2 inches deep from this surface to end up at the correct depth later on. And I'm going to use those tapped holes to mount this part to the faceplate for the first turning operations. That's why I'm putting them in now before all the turning's done. It's not ideal because it means uninterrupted cuts in the turning, but I don't have room to weld lugs on this thing to mount it differently. Otherwise, I do all the turning and then do all the drilling. So this is what we're going to do. Now, to control the depth, I only have my X and Y DRO installed at the minute. I haven't got the Z or the quill, Z or Z. So what I'm going to do, and I'm sure this is correct because I've seen Joe Pye do it, I'm going to bring the drill down to full depth on the quill and lock it. And then I'm going to go to a position where I can touch off on the surface here. And I'm just going to bring the knee up until the part touches. Then I'll retract the drill and then bring the knee up 2 inches. And that way when I'm drilling, I can just bring the quill down to its full extent and know that I'm at the right depth. Now, before I get too close, Now the actual depth of this hole is not super critical, it just has to be deep enough. So there, that's plenty good, so we don't chip the end of the drill. Now that can go all the way back. Zero the knee. And come up 2 inches, which is 20 turns of the crank. Now I know that when I go to full depth on this, I'll have a 2-inch deep hole, which I'll check after making the first one, just to be sure. Right, on we go then. Now, a bit more chat about the setup. I have here some shoddily fabricated trays, and that's because I'm going to run flood coolant here. I'd be better off with a mist coolant, but I don't have a mister. So I'm going to use flood coolant, and because the part hangs off the table, it goes everywhere. So this is just to get most of the coolant back into the recirculating system. It does make a hell of a mess, flood coolant, it really does. So this is just an attempt to minimize that. It will still run off places, but it shouldn't be as bad. So got to keep my return holes open. There we go, that's better. Oh, that's working. Yeah, there's a bit of drip in there, that's no surprise. I think I'm there. Yep, there we are. Now honestly, when I keep the pressure on, that drills through that stainless, no problem at all. Deburr that and get a depth measurement, which should be about 2 inches to the center of the drill point. Only need an approximate. Yeah, there we are. And given that I can't get, it's 1.9875, and given that I can't get the probe right into the very center of the drill point, that's just fine. I like it! So I'm going to continue now, because drilling the rest of the 8 holes is going to be much like that. I will bring you back once that's done. Oh, no, you don't. Get out of there. Got to find out where they're nesting and get rid of them. Now, next phase is to counterbore the through holes, and I'm going to counterbore them to finished depth. Even though I'm going to, on the lathe, I have to machine off and leave a boss in the middle of this. I have to machine the OD up to about here. I'm I'm finishing all of these features to their finished depth, just to save me putting this back up in the mill later on. It's just to keep setups to a minimum, really. So I've got a set of 4 end mills here, starting at 3/4 and then going up to 7/8, 1 inch, and then 1 1/8 inches. So not particularly difficult. I'll film the first hole each time I do a tool change and record that. And then after that, it will be time to turn this over, locate the bolt pattern and put a center in the other side, and then it's to the lathe. Okay, final depth of the counterbores is 1.325 nominally, and that allows for 40 thou of cleanup from this face to the final top of the boss that's going to be in the middle there. Not concerned about these unfinished areas out here, because that entire outer diameter is going to be turned down actually up to about there. And that 1.325 then allows for the machining that's going to happen in that region. So what I'm going to do is, on the progressive milling, is I'm going to take that down to, I'm going to leave, I think I'll go 1.3 on the intermediate sizes, and then on the last one that gives me 25 of cleanup on the bottom of the counterbore. Should work. Okay. Now, quill all the way down. Now, bring the knee up. I think what I'll do is I'll just do a scratch. I'll bring the knee up until this just scratches, and then we'll know that we're in the right spot. Yeah. That's a little bit more of a scratch than I would like, but I know that I'm leaving plenty of cleanup stock, so that's okay. So now, that out of the way, zero the knee and come up 1.3 inches. So that's 1 inch, 1.1, 1.2, 1.3. Shut that off for a minute. Let's see how it works. Let's see how that works on a slightly bigger cut. These are all done. Went reasonably well. I tried a bunch of different speeds and it cut just fine at all the speeds, but at slower speeds was a little easier to deal with the stringy chips. Anyway, next is to chamfer the hole at the bottom of the counterbore there, and I'm going to use the homemade chamfering tool for that.
Seeing you.